Hey guys, hope you are doing well and had a nice and relaxing weekend and are ready to tackle on this week. Good news is we only have 3 days this week. Um, Monday through Wednesday, Thursday is a staff professional day, professional development day for teachers and staff, and Friday had already been scheduled as an off day for everybody. So good news. Okay. So today we're going to go into new material. It's 8.4 multiplying and dividing rational expressions. And the one thing I will say before we move into this is that your factoring skills are going to come in really handy here. So if you're feeling really good about factoring, you like factoring the way that I like factoring, you're going to feel pretty good about this section. If you happen to be on the flip side where you never felt great about factoring, you're struggling a little bit, just know that this is going to require some quick factoring. I'm going to do the factoring pretty quickly. It may help if you look up some old notes. Everything is on Google Classroom. Look up some videos on YouTube or Khan Academy to get a refresher. Send me an email. I'll probably hold office hours this week on Google Hangout Meet, so join that. Um, but it is important, or it is going to be super helpful if you're solid with your factoring. Okay, so let's just hop into it here. There's going to be three sections we do here. The first is um, just simplifying, then we'll move in specifically into multiplying and dividing. All right, so first off, what are rational expressions? Rational expressions is a ratio of two polynomial expressions. Okay, um, so the steps here are listed for you. You're going to factor everything. Then you're going to simplify the monomials using exponent rules. Then you're going to eliminate common binomial factors. Okay, now before we actually get started, the one thing that's not included on these printed out notes that I do want you to know about is restrictions. So I'm going to write it over here on the left side. Okay, restrictions are on any value that makes the denominator equal 0. Okay, so anything you basically would just set your denominator equal to 0, and that would tell you any restrictions because we can't be dividing by 0. Okay, and then the only thing I want to note here is you want to determine this or base it off of um, the original excuse me expression before you cancel out. Okay, so let's go ahead and get started here. We're not going to do all the problems, but I did want to give you all of these just in case there's extra ones that you wanted to walk through and practice. But let's start with number one here. Excuse me, we are going to simplify. So um, you're just going to, and I'll do it for this time, I won't do it for all of them, but look at the numbers separate first. And so 20 over 14, this is going to reduce to 10 over 7. And then x to the 6 over x squared, this is where you would use your property of exponent rules. This is the quotient property, where you subtract the exponents, you get x to the 4th. So if you combine these two, you have 10 x to the 4th over 7. Okay, and then our restrictions, I'm going to put down here, right? This is going to be x cannot equal. So again, look to the denominator of the original function. We didn't have to factor it, so just the original. So what value is going to make that equal 0? Well, if you set 14x squared equal to 0 and you solve that, you're going to get x cannot be 0. Okay. Let's do the one right below it. Now this one's going to involve a little more work because there's some factoring here. Okay, so we got to factor the denominator. So let's first rewrite this. The top is just going to stay as y plus 8. The bottom is going to factor into y plus 8 times y minus 6. And now you're going to cancel out common factors. So the y plus 8, that leaves you with 1 over y minus 6. And that is your simplified expression. Okay, it's simplified again because there's no common factors between the numerator and denominator. Okay, and then if we talk about restrictions, y cannot equal, and now I would look to the factored form, which is still the original form, but now it's factored. It's a little easier to see. So before we cancel out the y plus 8, set each of those, y plus 8 and y minus 6 equal to 0, and solve. And you're going to get y cannot equal negative 8 or positive 6. Okay, now the video is going to stop and it's going to ask you to do number 4 or the next problem on your own. Go ahead and do that. A couple tips when you're working with Puzzle. If you can't figure out how to do something to the power of 2, if the toolbar to use the square button doesn't show up, go ahead and just do, caret 2. Do your best, right? If you can't figure out how to use a fraction, then just say the top colon and what your numerator would be, and then bottom or denominator colon what your denominator would be. Okay. And once you submit an answer, you need to submit an answer. The video will start playing again, and it'll be me going over this problem. Okay. All right. So here we go. Again, first thing we need to do is factor. So I'm going to factor GCF of 2 out of the top. That leaves me with r squared minus r minus 20. On the bottom, I also have a GCF. This time it's 8. So that leaves me with r plus 4. Okay, I'm not completely factored, so I'm going to keep factoring the top. And I'm going to get r minus 5 times r plus 4. Oops, that's supposed to be an r. And then the bottom stays the same. Okay, and then hopefully you cancel out common factors. The 2 divided by 2 and you get 1. 8 divided by 2 and you get 4. And so you should have a final answer of r minus 5 divided by 4. And then don't forget your restrictions. R cannot equal, and now look here where it's factored. Set r plus 4 equal to 0, so r cannot equal negative 4. Okay, we're going to do one more problem on this page before we flip to the second page. And that's number 5, and that's because of this little box on the outside. This has become important when we do this problem. So let's just go ahead and start like we normally would and start factoring. The top is a difference of squares. It's going to factor to p plus 7 times p minus 7, and the bottom is 7 minus p. Now, if you're looking at this thinking, well, there's no common factors, right? Because it's p minus 7 on top and 7 minus p on bottom. And that's, guys, what this is over here. Okay, so that's what these two represent. They look the same, but the difference is one of them, the p is positive on top, but on the bottom, the 7 is positive. So what can you do here? Well, you can rewrite it like this. So they keep the p plus 7 the same and keep the p minus 7 the same on top. But on the bottom, now take out a negative 1. And what that does is that gives you a negative 7 plus p. And now what you ended up doing is these now look alike because you took out the negative. So you can cancel those out. And you're left with p plus 7 divided by negative 1. Now, most of you are going to change that, and I would change it as well. You can write it like this, or you can write it like this. I'm going to write it like this. Okay, so what does that mean? So a minus b divided by b minus a, see what that ended up being is just negative 1. So we'll go ahead and write that over here because that might come up again later. Now your restrictions, p cannot equal, look up here again, p cannot equal 7. Okay, let's go flip to the next page. Now, what if we have to multiply? So the first page we were just simplifying. This page, the extra step is that you got to multiply. Okay, now here's my recommendation. You don't actually have to always multiply first. Okay, and it says it up here. It says with monomials, multiply, then simplify. When it's two binomials or trinomials, you can factor everything first, then simplify. Okay, so I want you to get comfortable whether it makes sense to simplify first and then multiply, or multiply and then simplify. Okay, now um, let's do number 9. So this one I'm just going to go ahead and multiply first, right? So my coefficients on top, my coefficients on bottom, my x's on top, my x's on bottom, and my y's on top, my y's on bottom. So on top I'm going to have 60 x to the 5th, y to the 7th. And I'm just using my properties of exponents there. Okay, on the bottom I'm going to have 36 x squared, y to the 4th. Okay, and you're probably thinking, well, can't you simplify more? And you are correct. So let's do that. You should get 5 over 3 x to the 3rd, y to the 3rd. And then don't forget your restrictions. X cannot equal, so you're going to look back up here. We didn't do any factoring, so you just want to set all those variables, any variable you have, even if you have more than one, set it equal to 0 and solve. In this case, you set that equal to 0, you just get x cannot equal 0. You also get that y cannot equal 0. Okay, let's do the problem below it. So this one's a little different because now we're actually multiplying binomials and trinomials. This, I want you to simplify, so factor, cancel out, instead of multiplying first. Okay, you could get the same answer, but multiplying first is going to take a lot more time and open yourself up to a lot more risk for error. Okay, so first let's factor. Now, you might notice this, we want to factor in kind of 2 steps. Let me first take out a GCF of 2, and then I'm going to factor that. Okay, so on the first term, I'm going to factor out a GCF of 4x. That leaves me with x minus 1. On the bottom, I'm going to factor this now. I have a 2 on the outside. This is going to factor to x plus 3 times x minus 1. The second term, the top is going to factor to x plus 3 times x minus 2. On the bottom, I have a GCF of 4x again. And this time, when I take the GCF out, I'm left with x plus 2. Okay, now you can simplify common factors. So here's the neat thing, guys. You can cancel x plus 3 and x plus 3, even though they're not with the same term. And that's because, remember, multiplication is commutative, right? Meaning 2 times 3 is the same as 3 times 2. That also means that, here's an example. If I have 5 over 2 times 2 over 7, right? I can cancel out these 2's and just leave it as 5 over 7. And that's essentially what we're going to be doing here. Okay, so I can also cancel out x minus 1, 4x, and 4x. And that leaves me with on top x minus 2, and on bottom 2 times the quantity x plus 2. And don't forget restrictions. X cannot equal. And now I would look here, and I would also look there for restrictions. Set each of those, wherever you see the x variable, set each of those factors or terms, because this is really the zero product property, set them equal to 0 to get your restrictions. You're going to, x cannot equal -3, +1, 0, or -2. Okay, I'm going to pause the video here. You're going to try the next problem on your own. Go for it. Okay, so hopefully you were able to work that one out. I'm going to just walk through it right here. So I'm going to start again by just simplifying by factoring. So the top I'm going to take out a 5v. I'm left with 2 minus v. On the bottom, this is going to factor to v minus 9 times v minus 2. Okay, second term on top is going to factor to v minus 9 times v plus 1. On bottom, can't factor that, so I leave it like that. Okay, let's see what we can cancel out. We have a v minus 9. Oh, we do that in green. V minus 9, v minus 9 cancel out. You can also cancel out this v, this v. We'll simplify the 5 over 15 in just a minute. Now, you may have noticed this. We have the situation that we had on the front page where these two are similar but just opposite signs. So if you remember going back to the front page, and I'll show it to you. I'm talking about this right here. A minus B divided by B minus A just equals -1. So you could go through and factor out the negative like I did in number 5 here, or you can just say, well, if I know that's true, that means what I highlighted in yellow here is equal to -1. So let me put that to the side here. 2 minus V over V minus 2 is just -1. So what am I left with? I have a 5, and I have a -1, and I have a V plus 1 all over 15. Okay, so let's just reduce that a little bit more. Okay, meaning these can reduce. So now I have -1 V plus 1 over 3. And you can distribute that -1, right? If you wrote it as negative V minus 1 over 3, that the same answer. One isn't necessarily better than the other. They're both correct. Okay, now restrictions. V cannot equal, so look here and look here. So V cannot equal 9, 2, or 0. So hopefully you're able to work that one through. Okay, last section, guys. Dividing. Now, there's literally one additional step when we divide that makes it different from multiplying. And that is to divide rational expressions, you're going to multiply by the reciprocal. So that's the first thing you want to do is you want to flip the second term. Okay, and then you're just going to be multiplying just like we did in the problems above. So let's start with number 14 here. All right, so I'm going to write a note, flip, and I'm going to kind of do it in one step. I'm going to flip and factor in the same step. So let's go ahead and factor the first term. The 10 stays the same. On bottom, I have a GCF of 4. All right, the second term, I'm going to flip, and then I'm going to factor. So this is going to be x plus 3 times x minus 2. And my new denominator, I'm going to take out a GCF of 2x. That leaves me with x plus 3. All right, let's cancel out common factors. We have an x minus 2, x minus 2, x plus 3, x plus 3. What are we left with? 10 over 8x, but that can be reduced further to 5 over 4x. That one worked out pretty nice. Now restrictions, x cannot equal, so now you want to look here, and you also want to look here. X cannot equal 2, 0, or -3. Okay, and finally, I want you to try the next problem that shows up, which is number 15 here, on your own. Once you hit submit, the video will continue playing. Please watch my explanation of it so you can know whether you did it right. And in case you got stuck, you can see how I approach this problem. All right, go for it. Okay, so number 15. Again, we want to flip the second one, and then we're going to factor everything out. So GCFs, a lot of GCFs going on here. So the first term, I'm going to take out a GCF of 2a. This leaves me with a minus 6. Or I'm sorry, 2a squared. Leaves me with a minus 6 on the bottom. Factor that to a minus 6 times a plus 2. The second term I'm going to flip, and then I'm going to factor the top. So that becomes a minus 5 times a minus 3. And then I'm going to factor the bottom. GCF here is 8a squared. That leaves me with 3 minus a. Okay, so let's find some common factors here. We have an a minus 6. We have an a minus 6. We know that we're going to be able to do something. Well, actually, let me do it this way. We have an a squared. We have an a squared. The 2 and the 8 can be reduced. And then, hopefully you're catching on, we have this again. Right? A minus 3 over 3 minus a. So again, a minus 3 divided by 3 minus a. Going back to on the original problem, on the first side, as well as on number 12, okay, a minus b over b minus a, this equals -1. So I am going to reduce that to -1. So what do I have left here? I have 2 times a minus 5 times -1. Okay, I'm using this as my putting it on top. On the bottom, I'm left with a plus 2 and an 8. Okay, let's reduce these two. You may have already done that, or you maybe did that before, but let's reduce those. And I'm going to actually also distribute this. So now I have negative a plus 5 on the bottom. 2 over 8 reduces to 1 over 4, so I have a 4 on the outside and a plus 2. Okay, now some people will ask, do you need to multiply that or distribute that 4 to the a and the 2? And the answer is no, you absolutely do not have to. Okay, when we're multiplying and dividing, there's no rule on what your final answer should look like. So this is correct. Okay, this is also correct if you write it like this. That's also correct. Okay. All right, and last thing is our restrictions. A cannot equal, look back at your denominators. So it cannot equal 6, negative 2, 0, or 3. Okay. Hope you guys got through those okay. Please don't hesitate to reach out if you have any questions. And hopefully these are helpful for the homework that you have. Thanks, guys. Take care.